Okay, now let's talk about how rules are defined in Prolog. A rules body consists of calls to a predicate, which are called rules goals. A predicate is either true or false based on its terms. If the body of the rule is true, then the head of the rule is true as well. So of course, I have, as mentioned before, a rule is something that contains multiple facts. So if multiple facts, if for example, I'm using and clause, if all facts are true, then that means that rule must also be true. Now let's look at an example. Let's just say that I have these four facts here. The facts say that Fred is a parent of Jack. It's a fact. Fred is the parent of Elia. Fred is the parent of Paul. Dave is the parent of Fred. So we've got these four facts here. Okay. Now, these are independent facts on its own, and each fact has two parameters as it can be seen here. But I am now going to define a rule. The rule is for a grandparent. The rule states that if G, as you can see here, these are variables because it's a capital letter. G is a grandparent of S if G is a parent of P and P is a parent of S. So now, I mentioned here that a rule has more than one facts in it. And if the rule requires that all facts are true, and if they are true, in fact, then the rule is also true. Now let's just say that my rule is stating that G is a grandparent of S. Now, how can I determine that G is a grandparent of S? This fact for G and S will only be true if G is a parent of P, that's true, and P is a parent of S, that's also true. If both of these sub facts are true, that means this rule will also be true. And as mentioned before, if it's a rule or if it's a complete statement, if it's a fact, it has to end with a full stop. So as you can see here, even though I'm mentioning multiple facts here, I have two facts here, they are ending with a full stop. So as long as I don't have a full stop, it won't, my Prolog may generate an error and it will not consider this as a complete statement. So whenever you have a complete statement, may it be a rule or a fact, it has to have full stop here. Secondly, this and representation and if representation is used in your Cambridge exams. So you are welcome to use this as well. And most marking schemes are mentioning this representation. But in reality, Prolog does not use the word if. In fact, it uses this symbol, this semicolon. No, it's not semicolon, this symbol right here. Okay, now this symbol is interpreted as if, and a comma is interpreted as and. And if this was a bar, for example, what's the bar look like? Let me show you. If it's something like this, then this is treated as an or. But if you are comfortable in writing in the actual words, use all caps and you can write the actual words as well. But if you want to use symbols, you can do that as well. So this is and this is what or means. So this basically means A or B, something like this. So this dash, this vertical line represents or. Okay, so this exact same rule is written in Prolog like so. So G is a grandparent of S. Again, we got variables here. If G is a parent of P and P is a parent of S. So if this G and S satisfy these two subrules, then G is in fact a parent of S. So that's one example of a rule. Similarly, let's see the rules for sibling. Now, as you can see here, I don't have to write it in a single line. I can write it in multiple lines as well, but these symbols are still significant. So I have to have a comma where I want an and I have to add a full stop mark, a full stop where my statement is finishing. So the rules are still the same, but I can write it in multiple lines. That's okay. Now this is one rule, and the rule is for sibling, and the rule states that A is a sibling of B if B is a parent of A and P is also a parent of B. So if these two rules are satisfied for A and B, then that means the A or B are sibling. So you check it out. If you have, say, for example, two brothers and sisters, Hannah and Ahmed. So I've got two children, Hannah and Ahmed. Are they siblings? If Hassan is the parent of Hannah and Hassan is also a parent of Ahmed, that means Hannah and Ahmed are siblings. And that's how it works. In fact, I have tested this here somewhere. Let's check it out. Anyway, let's see this example. Fred is a parent of Jack. Fred is a parent of Elia. Fred is a parent of Paul, and Dave is the parent of Fred. So let's see, we have defined the rule grandparent over here. Grandparent, G is the grandparent of S if G is the parent of P, P is the parent of S. And A is the sibling of B if P is the parent of A and also P is the parent of B. So we defined all of our knowledge base here, including these facts and these two rules. This is my complete knowledge base for this system here. Now, let's say that I run a query in which Jack, I'm checking who is the sibling of Jack. Who is the sibling of Jack? So as you can see here, it runs through the code and it says that sibling rule states, okay, I will associate A with Jack. So I know one value here. So A with Jack, and I don't know X right now. So I'll see, is P the parent of Jack? And who else is P the parent of? So as you can see here, with Jack, Fred is the parent of Jack, as well as Fred is also the parent of Elia, and Fred is also the parent of Paul. As you can see here, Elia and Paul were returned because it instantiated, according to Jack as the first value, it instantiated P, Fred, with A as, Jack, as well as B as, parent of, say, Paul as well. But the thing is, let's look at this again. If I have a sibling rule that says A is sibling of B, and my query has already associated the first parameter with Jack, so now I know the first value, Jack. My rule states that P is a parent of Jack, and who else is the parent? And the same parent must be of some other sibling as well. So let's just say, first of all, since I know this value, then this value is Jack. First of all, I'll ask, who is the parent of Jack? What value will P be associated with? In that case, Fred will be associated with P right now. After this first fact, since I know the value of A, which is Jack, I will see what fact satisfies the value second parameter with Jack. And as you can see here, my first rule satisfies the rule, the condition in which the second parameter is Jack. So I got A as Jack, and now this rule satisfies that criteria. The second parameter must be Jack. Okay, now since my second parameter matches Jack over here, that means this P must be Fred. P must be Fred. So because of this first rule, P has been instantiated with the value Fred. Next up, I see, okay, now I know what P is. I will see who else is P, father of. So as you can see here, my first value with Fred as P is Jack. The first value is Jack. So that's why, as you can see here, The X is instantly given Jack, because when I assign Fred as my P, and I start seeing who is Fred a parent of, the first fact that says Fred is a parent of Jack, because of that, Fred X is B is associated with Jack right away. And that's why Jack is being shown here. Apart from that, Fred is also a parent of Alia, and Fred is also a parent of Paul, and that's why Alia and Paul are mentioned here. But try to understand the sequence of events that are carried out here. First of all, I'll repeat here. Why is Jack again showing? What does it, why does it doesn't make sense? Jack is a sibling of Jack. Why? That's basically what it means. Jack is a sibling of Jack. Jack is a sibling of Alia. Jack is a sibling of Paul. But Jack is a sibling of Jack doesn't make sense. And why is this value here? What happened here is that I have instantiated the value, because the rule sibling requires two parameters, A and B. Assuming that this is A and this is B, I don't know what B is. I'm going to find out, but I know what A is right now. So that A is given Jack. So when I entered this rule, the first rule says that some P parent is a parent of Jack. So according to my knowledge base, if I have Jack in my second parameter, the first P assigned here is Fred. Okay, so that means my P becomes Fred. So afterwards, now I know the parent. I know the value of P. So now, first of all, I want to establish who is the parent P of, so or Fred of. So according to parent clauses or parent facts, with the first parameter being Fred, the first fact I see is Jack. So that means this B must be Jack. This B must be Jack. Because I satisfied with this root fact here, I established that Jack is a parent of some P, and based on that fact, Jack is a parent of Fred. So P, after this fact, it was established that P is Fred. Now I want to establish, if I know what P is, I know who Fred is, I want to see who else is Fred a parent of. According to my knowledge base, with first parameter being Fred, the first fact I see is Jack. So that means instantly, based on this rule, I assign B with Jack. And if I assign B with Jack, that means this B is also Jack, and this B is actually X over here. So that's why it says X is equal to Jack. So first, that is Jack. Afterwards, the next Fred parent is something of, or a parent of some X, satisfies the rule with X is equal to Alia. So B becomes Alia. And since B becomes Alia, this B becomes Alia, and this X becomes Alia. That's why X is equal to Alia. Similarly, the third fact where Fred is a parent of someone is where B is equal to Paul. So if B is equal to Paul, the B is translated here, and that B is translated to this X over here. And that's why X is equal to Paul as well. But the reason that X is equal to Jack is because the first instant where I find out the Fred is the parent's name, and I start looking for the children of Fred, the first fact I see is that Jack is the child of Fred. That's why Jack is shown here. Now, to avoid this problem, what I can do is I slightly modify my sibling clause. And in which case I say that A, if I have Jack here, I cannot have Jack here as well. So in that case, if A or B and B end up being the same, because of which, you see why I first find out who B is, I found out Fred. Now, if I have Fred here, and the first fact I see is Fred, parent of Jack, that means B is Jack. But wait a second, B means Jack, B is Jack, and I already established that A is Jack. So since A and B are same here, this rule over here avoids the possibility of Jack being returned as a sibling. So that's how I modified this rule. So additional rule here, so additional fact here, that A and B cannot be same, because of which my final results do not present Jack as a sibling of Jack. They result everything else. Okay, just to make things clear here, this statement is read in this way: A is equal to B. A is not equal to B. So again, as always, P is a parent of A. Fred is parent of Jack. A is sibling of B. A is not equal to B. Okay, so this is how it's read. Okay, following this, we have a knowledge base. I assume that we're writing a knowledge base for your own family. You can include predicates. For example, this is example from the book. So I have a predicate male. Fred is a male. This is one fact. Alia is a female. That's one fact here. And if I were to write rule for father, what would it look like? So check this out. I have three facts written here. Hassan is a male. Hassan is the parent of Hana. That's a fact. Hassan is a parent of Ahmed. That's another fact. And a rule states that F can be a father of C if F is a male and F is a parent of C. Now, let's see how this query will work. First of all, I am running the query. Hassan is father of Ahmed. Okay, so that means instantly when I visit my knowledge base, I would look for the predicate father. I found it right here. So that matches this name right here. So that means F must be Hassan and C must be Ahmed. So to make sure that this fact, this rule is true, I have to first verify that is F, in which case it's Hassan. Is there any rule that states that Hassan is a male? Is there any knowledge fact in my knowledge base that states that Hassan is a male? Yes, there is. We have found such a knowledge base. We have found such a statement that states that Hassan is a male. So first part is true. Okay, so again, we got first, I am testing out this rule. Hassan is father of Ahmed. So I have instantly associated F with Hassan, C with Ahmed. So with F as Hassan, I have to check if there is any fact that's a male fact that has Hassan in it. So yes, I have a fact in my knowledge base that has male with Hassan as its predicate. So I'm using that over here. So again, after that, since I've established this one part is true, let's check out the second part of this rule. Is there any fact that states that Hassan is a parent of C? Now C, I just according to this rule, C is instantiated with the value Ahmed. So is there any rules that states that Hassan F is equal to Hassan? Is Hassan a parent of Ahmed? So is there any rule that states that Hassan is a parent of Ahmed? Yes. So since these two rules are, so these two facts have been proven correct, this is true, and this is and, that means this rule in which Hassan is a father of Ahmed is also true. And as you can see, my prologue returns the value true. Same thing goes with Hassan is father of Hana, that's also true. But now I can also use anonymous variable. Now, how is this interpreted? Is Hassan a father? Is Hassan a father? It doesn't matter of who, it just simply returns yes, true, Hassan is the father, because there's at least one situation in which Hassan is a male and is at least a parent of someone. It doesn't matter of who, but since he's a male and he's a parent of someone, it will be considered as true. Yes, he is a father. So of there's anonymous variable, you don't want to know who of who, you just want to ask is he a father or not, and yes, he is a father.